Next, we have my friend Giuseppe Bruno, who's come from a long way. Let me just simply say that Giuseppe has worked for the Bank of Italy, since 1989? 89. I'm not going to read the bio, but I am going to read part of his message to me, which just made me cough up my spleen. Please feel free to summarize, modify my bio in any way you deem necessary. I'm sure it's the same for everybody else about my university results. Please cut away anything superfluous. You, my friend, you rock. Giuseppe Bruno, thanks.
Thank you. Okay, here in this talk I'm going to describe some of the experience that I've been doing with my friends at the research department in the Bank of Italy, testing Lustre against different file systems and on different platforms. And okay, here we have just a short outline of the presentation, so I'll say something about the motivation, and then I'll describe the benchmarks that we have employed to test the different file systems. And I will conclude with some details, very short details about Lustre Friends. And especially I will spend some words about the POSIX compliance that we've been hearing in other talks yesterday and this morning. So the first point is when we need to run and design a new computing platform. And in running a computing platform, we came over functional and performance problems. And analyzing the benchmarks and the compliance tests, I'm pretty sure that we can mitigate and work around and sometimes even remove some of the issues. And among the issues that we have been found, we had some POSIX compliance issues, and we signaled some of these to the OneCloud say backtrack, and of course we can find performance issue in reading and writing data on the OSTs, or even reading and writing metadata on the metadata target. While when we design a new computing platform, and this is what we are doing right now, we need to meet all the user requirements. And I have discussed some of them during the panel, and essentially at the research department of the Bank of Italy, we have a very diversified I/O workload. Essentially, we have some, I would say, few large sequential I/O patterns with files that range from 10 to almost 100 gigabytes. And we have millions, about 16 millions of files, and whose size is less than 4 kilobytes. And moreover, we need to make some cooperative production of Windows Office documents whose data are the outcome of some processing on the Linux cluster. And finally, we have also some batch jobs that interacts with these Windows files, interact just to grab some data and to produce different results. Okay, so for meeting all these user needs, we need to have a Lustre file system that works as a permanent storage space. So in our case, is used for home and group directory, and considering that the file system is a small one, is about 20 terabytes. We back up the file system with incremental backup every day, and we have a full backup every month. Moreover, we need quotas for managing a fair disk space allocation among users and group of users. And some of our users need to apply extended access control lists to their files to regulate the access. And most of the computing is done with the statistical and algorithmic packages, and most of them are scalar applications. Furthermore, we have also some web applications that access the Lustre file system, simply some wiki that are related to some themes. Oh, and now we go to the benchmarks that we have assembled together, and so essentially we had some micro benchmarks and some application benchmarks. As far as micro benchmarks are concerned, we considered this suite. So we ran this suite of micro benchmarks, Boni++, IOZone, and DD and MD test with some modifications. We had to modify the source code, and NBENCH on the different file systems that we have been testing. And there are other two benchmarks that I consider valuable, but we didn't apply them for time constraints, essentially. The meta rates and the flexible file system benchmarks. So here we have the flags that we have used for these commands. So we used the Boni++ for both data and metadata performances, and the IOZone for this particular size of file size. Then we use the DD commands for both reading and writing, and finally we have an MD test with 6,000 files and 6 directories. Okay, here we have some tables. I'm going to present some tables, and on each of these tables, I wanted to write clearly that the performance measures are not easily comparable. So I'm not going to say that one of these is better of the other for a very simple reason, that first of all, I have signed some NDA with some of the people who have provided, some of the company who have provided us the possibility to make these tests. And besides from this NDA, we have the practical reason that this timing depends on really many different hardware and software parameters that is not easy to control. But it is still important to consider the different file system, and at least following along one column, so with the same file system, the behavior with respect to the different tests. So here we have writing performances, and in the first column we have our production environment. So that is we are using Lustre 1.8 point something, and and we have this behavior in writing data. Then in reading data, we have, of course, better performance, and we have some problems with taking into account caching behavior of the different tests. And that's why I added an extra row at the end of the table where we have, for some of the file systems that we have tested, we have the reading performances when we read the file from different nodes with respect to the node to the writing nodes. And here we have some test, I mean a table with the MD test and the Boni++ in number of creation for seconds. And we had this, might be worth mentioning this strange behavior, because here the GPFS 3.4 and NFS mount are with the same hardware. Essentially they are exactly with the same hardware. The difference is in the software, because this one is just an NFS mount over GPFS 3.4, and we measure these values that are really, I would say, strange. They would need further investigation. And then, as far as, okay, we have been talking quite a while this morning about the possibility to use Windows for reading files from the Lustre file system. Well, at the Bank of Italy, the using of these files is not for high-performance computing. Usually, we put Office files, Word or PowerPoint, on the Samba share simply for cooperative work. And we have tested this, the performances of this setup using the SMB Tertiary benchmark, considering 10 clients. And the only thing that I want to raise the attention about this flag here, minus uppercase L, that is used. So we tested with and without the opportunistic locks on the Windows platform. And we are going to see very, very nice results about this. So here a short explanation of the different flags that we have been using. And I've already talked about the minus L flag, and the minus N is for the number of different clients, so to simulate traffic of many Windows stations. And the minus C and the final NBENCH are two flags that somehow they go together, because NBENCH explained that we are going to use the kind of load description, the kind of workload that is in this file, client txt, that is provided by the NBENCH benchmark. And here we have the results. Of course, the usual statement at the beginning, and we should have a behavior like this. So with the opportunistic lock, we should have a higher performance with respect to the same test without the opportunistic lock. And this works for almost all of these tests, but it didn't work for this case and this case. Oh, sorry, thank you. It didn't work for the final column, this one that we tested with Lustre 2.1, and this one that we tested with the GPFS 3.5. And of course, we have to investigate the reason for this behavior. And now for the application benchmark that is mimicking one of our workload, because at the beginning I said that we do not have an easy description of the I/O workload that is used in the research. But for one of this application workload, okay, we have written a set of shell scripts that allow us to check the behavior of the file system in writing and deleting trees, file trees. And most of the activities are metadata intensive. The application benchmark breaks down essentially in the following activity. First of all, to create an empty tree with the number of branches and the depth of the tree that is parameter. Then we fill each leaf of the tree with a byte sequence. We use either dev0 or dev urand. And then another important metadata intensive task is that we change the group ship for each file of this tree. And we update the byte content of each leaf or file of the tree. Okay, and here are the results that we have been collected. And of course, also here, the purpose is just to show the amount of data that have been collected, and of course, is not aimed to give a mark one of these file systems with respect to the others. It is, of course, a good news for me, for me and for the Bank of Italy, that all these columns show numbers that are smaller than the one that I have on the first column. So this means that no matter how do I pick the following file system, I'm going to get better results. Okay, here just a summary of the file system that we have been considered in this research. So this essentially 6 file systems, but for GPFS we tried also this NFS mount. And finally, okay, just this last minute, I will describe something about the POSIX compliance. We downloaded a POSIX compliant test, and I'm sort of disappointed to realize that I didn't find a recent POSIX compliant test. So here I summarized some of the tests. I mean the POSIX compliant test produce a table that is something like 70 or 90 pages. And I just took the summary of the results. And here with the red color, I hope, well, I think I made a problem instead of improving the visibility. But anyway, with the red color, I wanted to show the file system that produced better results with respect to the others, because in this case there is no problem with performances. And okay, just to give some conclusion, that I do believe that getting measurable description of the user requirement is very important, and finding the functionality that are more frequently employed, so the profile of the workload is very useful. And just to complete the thing that I just gave some suggestion that MD test benchmark, Microbenchmark might be improved in introducing the measure on the change group and the change mode operation per second. Okay, thank you very much.